Remember when your car was new? The engine was full of life, acceleration was crisp, and the throttle response was instant. It just felt eager to go. But as the miles rack up, something changes. The engine still runs, but it feels tired. Overtaking on the highway requires more planning, fuel economy isn't what it used to be, and the car just seems to struggle a bit more. This power loss doesn't happen overnight. It creeps in so slowly that you might not even notice until one day you realize your car just doesn't feel the same. So, what's really going on? Engine power loss isn't some great mystery, and it's rarely caused by one single, catastrophic failure. Instead, it's a story of 1,000 tiny cuts, small, gradual changes happening deep inside your engine, slowly chipping away at its ability to make power efficiently. Understanding these hidden causes is the key to maintaining your car's performance, avoiding expensive repairs, and keeping that engine running strong for years to come. Today, we're going to pull back the curtain and reveal exactly why your engine loses its punch, and more importantly, what you can do about it. Let's start with the most fundamental cause, internal mechanical wear. Every engine is a precision machine built with incredibly tight tolerances. For an engine to make power, pistons need to form a perfect seal against the cylinder walls to trap the explosive pressure of combustion. But over thousands of miles and millions of engine revolutions, friction takes its toll. Even with the best oil, microscopic wear on piston rings and cylinder walls is unavoidable. As these tiny gaps get bigger, some of that precious combustion pressure leaks past the rings instead of pushing the piston down. This is called blow-by, and it's a direct loss of power. This kind of wear won't trigger a check engine light. The engine runs, but it just feels weaker. You might notice acceleration is a bit sluggish or that it takes an extra crank to start on a cold morning. Many people just write this off as normal aging, but it is actually a physical loss of the engine's ability to compress air and fuel. Next up is a silent performance killer: carbon buildup. Modern engines are marvels of efficiency, but combustion is never 100% clean. Over time, sticky, black carbon deposits build up on intake valves, piston tops, and inside the combustion chamber. This is a huge problem, especially for modern direct injection engines where fuel is sprayed directly into the cylinder and no longer washes over the intake valves to keep them clean. As this gunk accumulates, it restricts the flow of air into the engine, like a clogged artery. Worse, these carbon deposits can create hot spots. To prevent a dangerous condition called engine knock, your car's computer will automatically pull back ignition timing. This is a self-preservation move, but it comes at a direct cost to performance. So your engine feels sluggish, not because something is broken, but because it's actively detuning itself to stay safe. Now let's talk about fuel. Your engine can't make power without it, but problems with fuel delivery are another hidden reason for a tired-feeling car. Fuel injectors are designed to spray a perfectly atomized, cone-shaped mist of fuel for a clean, powerful burn. Over time, tiny deposits from fuel additives or contaminants can start to clog these injectors. When this happens, the spray pattern gets disrupted. Instead of a fine mist, you might get a weak stream. This leads to an imbalanced engine, where some cylinders run lean with too little fuel, and others run rich with too much. The result is reduced power, rough idling, and poor throttle response. The fuel pump itself can also weaken with age. It might supply enough fuel for gentle cruising, but when you put your foot down and demand power, a worn pump can't keep up the pressure. This causes hesitation and a noticeable lack of top-end performance. Again, since the car still runs, many drivers never suspect a fuel delivery issue. Just as important as fuel is air. An engine is essentially a big air pump, and it needs a massive, uninterrupted supply of oxygen to burn fuel effectively. One of the simplest and most overlooked causes of power loss is a dirty air filter. It's a cheap and easy fix, but if it gets clogged, it's like forcing your engine to breathe through a straw. But it's not just the filter. The throttle body, which is the gateway for air entering your engine, can get coated in a layer of grime and/or residue. This buildup can interfere with the smooth movement of the throttle plate, causing a delayed or inconsistent response when you press the accelerator. On top of that, the sensors that measure all this air, like the mass airflow sensor, can get contaminated or drift out of calibration over time. When these sensors feed bad information to the engine's computer, it makes the wrong decisions about how much fuel to add and when to spark. Even tiny errors here can add up to a significant power loss, all without ever turning on a warning light. The ignition system is another critical piece of the puzzle. Spark plugs don't last forever. As their electrodes wear down, the spark they produce becomes weaker. A weak spark can't fully ignite the air-fuel mixture in the cylinder. This incomplete combustion means you're not getting all the energy out of the fuel you're burning. It wastes fuel and robs you of power. The ignition coils that generate the high voltage for the spark plugs are also subjected to extreme heat. Over time, their internal insulation can break down, weakening their output. A failing coil might work fine at idle, but under the stress of acceleration, it can misfire. Your car's computer will detect this and may even cut power to that cylinder to protect the engine and catalytic converter, making the car feel incredibly dull and unresponsive. Of course, we have to talk about lubrication. Engine oil is the lifeblood of your motor. It does so much more than just reduce friction. It cools critical parts and carries away contaminants. When you skip oil changes or use the wrong type of oil, you're accelerating wear on every moving part. As oil breaks down, it forms a thick, black sludge that can clog up narrow oil passages. This increases friction, which means more of your engine's energy is wasted just overcoming internal resistance instead of being sent to the wheels. Many modern engines also use sophisticated variable valve timing systems, which rely on clean oil and precise oil pressure to work correctly. Sludgy oil or low pressure can mess up the valve timing, leading to a major drop in torque and responsiveness across the entire rev range. Even your cooling system plays a role in how much power your engine makes. Engines are designed to operate in a very specific temperature window. If your engine starts to run even slightly hotter than normal, the engine computer will again step in and reduce ignition timing to prevent damage. This is a direct power cut. A partially clogged radiator, a thermostat that's getting old, or a water pump that is weakening can all lead to this subtle overheating that never quite triggers a warning light but still quietly saps performance. And don't forget the exhaust. A clogged catalytic converter acts like a cork in your exhaust pipe, creating back pressure that makes it hard for the engine to expel spent gases. This chokes the engine, reducing its ability to breathe in fresh air and fuel, killing power output. Finally, let's consider how all these things come together. Modern engines are managed by complex electronic strategies. As all these components, sensors, injectors, coils start to age and their performance drifts, the engine's computer is constantly adapting. Often, its priority shifts from maximum performance to ensuring reliability and meeting emission standards. This means the computer might make the throttle response a little softer, the timing a little less aggressive, and the overall power delivery more conservative. The engine works perfectly fine, but it loses that exciting edge it once had. Even your driving habits matter. Lots of short trips where the engine never fully warms up can accelerate carbon buildup, while constant low-speed city driving prevents the engine from getting hot enough to burn off those deposits naturally. All these factors, wear, deposits, fluid degradation, and electronic adaptation, combine slowly over time. No single issue is a disaster, but together, they create a steady decline in performance. But here's the good news: much of this power loss is not permanent. It's often reversible. A professional intake and valve cleaning can remove years of carbon buildup. Replacing worn spark plugs and coils, cleaning fuel injectors, and changing a clogged air filter can make a world of difference. Catching up on oil changes with the correct, high-quality oil can restore lubrication and proper valve timing function. Many drivers are absolutely stunned by how much power and responsiveness returns after addressing these hidden, neglected issues. Engines don't just lose power because they're old. They lose power because a collection of manageable issues builds up over time. By understanding what's happening under the hood, you can take proactive steps to fight back, restore that lost performance, and enjoy driving your car again. Thanks for watching. And don't forget to like and subscribe for more tips on keeping your car running its best.